After 5 seconds.
Alright, so we're going to do a 2-sample t-test for our data. And we're going to define the mu1 as the average time of cube 1 solves, and mu2 as the average time of cube 2 solves. We're going to check. So it's independent, random, it's less than 10% of the population, and it's approximately normal because N1, N2 is greater than 30, or N1 and N2 are both 60, by the way. And DF, we're going to plug that into our calculator, and we already plugged that in, so we know that it's 113.666. So mu1, we found that the average was 44.13. mu2, we found that it was 51.43. And our omega 1 is equal to 8.87 standard deviation, and omega 2 is 10.81. So now our HO is that mu1 is equal to mu2, but our hypothesis is that they're not equal. Now we just plug in all this stuff to our calculator, and we find that P has a value of 9.6112 times 10 to the negative fifth. For comparison, we used alpha equals 0.05, and as you can obviously see, P is much less than alpha. And since that's the case, we have significant evidence at alpha equals 0.05 to suggest that the average times between the two cubes are not the same.
Okay, so for shape, both graphs are symmetrical. For center, cube 1's center is lower than that of cube 2's. This shows that it is quicker to solve. And for spread, cube 2 has a bigger range, which shows that there is more variation. And so all that put together, we can conclude that if Alvin uses cube 1, he will solve it in a smaller interval,